Aloha kako. Welcome everybody to the second in a series of 4 workshops on breadfruit, sponsored by Kahumana Farms. And we're happy to be here to share today a bit about what we've learned and experienced with breadfruit. My name's Noa Lincoln, and just a brief bit about me. I'm a professor at the University of Hawaii at Manoa in a position called Indigenous Crops and Cropping Systems. Been in that position for about 5 years now and work on a range of different crops and growing techniques that are associated with our traditional agriculture here in Hawaii. We also manage a farm, the Malakala Ulu Cooperative, located in South Kona on the Big Island in Ke'e Ahupua'a. And here we're restoring the traditional agroforestry systems, the breadfruit agroforestry system that existed in that South Kona region. I am also the production advisor for a couple organizations, including the Hawaii Ulu Producers Cooperative, which represents about 100 breadfruit farmers, primarily on the Big Island. And so we work with a lot of breadfruit growers over there to understand their production and try to help troubleshoot and improve growing of breadfruit. And also for Kuleana Farms, which is a sugarcane and rum producer on the Big Island. And then I also work with a number of organizations focused on agriculture and traditional growing methods, including Ulumau Puanui in Kohala, Hawaii Island, where we have some experimental plots restoring the traditional sweet potato cultivation of the area. The Kona Producers Cooperative, which manages a state-owned facility focused on crop aggregation in Kona. The Amy Greenwell Ethnobotanical Garden, which focuses on our preservation of crops and other endemic plants to Hawaii and helping distribute those and educate about those crops. Aina Momona, which is a land management based organization on Molokai, and also on the Farmers Union United Kona chapter board. So like I said, this is the second of 4 workshops in the series. We did hold the first workshop at Kahumana back in February of this year, and in that workshop we really focused on the history of breadfruit in the Pacific and specifically in Hawaii, as well as kind of contemporary production, where we are in Hawaii and globally in terms of growing breadfruit markets and trends, things like that. Today we're really going to focus in on breadfruit habitat, where it grows and where it grows well, breadfruit varieties and their differences and their identification, and also phenology, or the seasonal timing of breadfruit production. Our next workshop will really focus in on the management aspects of the trees themselves, so covering things like pruning, propagation, orchard planning, nutrient management, and so on. And finally, our fourth workshop will focus on the kind of harvest and post-harvest stages, best practices around what you do with the fruit once you cut it off the tree, processing, preparation, and hopefully that workshop at least will be in person again, so we can also do some taste tests and share some dishes and recipes as well. So we'll jump right in and start with habitat. This is probably what we get asked about the most, about people asking, will breadfruit grow at our specific location? So we've done quite a bit of work trying to understand this in a comprehensive way. And so we'll share a little bit about the work we've done and what we've learned through that. I do want to start by saying that Hawaii is probably one of the best places in the world to do this work because of our amazing ecological diversity of the islands. And this is because we have these just amazing gradients here in the state. Our islands emerge from a stationary hotspot. So you have this wonderful age gradient from brand new, fresh, hot lava on Hawaii Island up to 5 million-year-old, highly depleted soils up on Kauai and Niihau. And on top of the age gradient, you can overlay some of the most impressive rainfall gradients on the planet. We have areas that are classified as true deserts in Hawaii, and we also have some of the wettest spots in the world. And sometimes those locations are separated by, just a handful of miles. And this interaction between rainfall and lava flow age creates a whole range of soil types and soil properties. We have high mountains, so we have substantial temperature gradients. And because of this, all these huge gradients in our environment, we can use that to really understand where plants or crops will grow or not grow. So over the last, probably like 8 or 9 years now, we've mapped about 3,000 breadfruit trees in the state, and we have filtered these trees to kind of represent naturalized trees, or trees that are growing without substantial human intervention. So trees that are subsisting on the native soil and the natural rainfall. And so this map here shows about 2,200 trees that are kind of occurring in a naturalized state. And we can use the distribution of these trees to look at the environments that they occur in and start to train our understanding of what breadfruit needs to survive. So we can take those trees and kind of develop parameters, environmental parameters around things like temperature, rainfall, soil pH, and so on, about where they exist. And so here we're showing both the absolute ranges, and this kind of means that once you cross this threshold, breadfruit will not survive, or if it survives, it'll do extremely poorly. And in particular, we get a lot of questions about, will breadfruit grow in the upcountry areas? And so this 17 degrees Celsius is kind of a minimum temperature, average annual temperature that breadfruit will survive at. You can go online, the Hawaii Rainfall Atlas and the Hawaii Evapotranspiration Atlas, managed by Tom Giambaluca at the University of Hawaii. And you can go onto their interactive maps, find your location, click on your location, and get all this type of information for your specific spot and see if you fall within these ranges. So again, we kind of have these absolute ranges that say breadfruit just cannot survive outside of that range. And then you also have these optimal ranges on the right, saying that okay, it'll survive up to 17 degrees or down to 17 degrees Celsius, but as you get close to that 17 mark, your trees are going to be doing poorer and poorer. And so you really want to be in this optimal range if you're going to be looking at production. So for instance, for temperature, you kind of want to be above 21 degrees average annual temperature. To really see the full productivity of a breadfruit tree. So we can take these parameters and these ranges And one of my PhD students right now, Kalisi Mausio, helped to convert these into habitat suitability maps, um, and basically visually depict then where breadfruit will do well and where it will survive and where it will not grow at all. So on these maps, the green areas are where you see good full production potential of breadfruit. And as you get into the red, that's where it'll survive, but your production is declining. And then anywhere that's white, essentially breadfruit will not survive on its own. Of course, this doesn't mean you can't grow it there. We can irrigate, we can amend soils, we can change our environment. But as far as the natural environment, if you're going to have a tree subsist on its own, um, this map depicts pretty well where you can and cannot grow breadfruit. The little plus marks on this map, these are about 60 producer sites, 60 farms that we use to validate this model. And at these farms, we actually looked at their tree health, their tree productivity, and used that to check this model. And essentially our model operates, above about a 90% accuracy, which is really quite good in the modeling world. So yeah, I think we can take this map as a pretty good, accurate representation of breadfruit habitat in Hawaii. And again, because Hawaii is such an amazing place to do this work, we can actually take these results and apply them globally. And just as a brief side here, we can look at the global breadfruit habitat distribution. And finally, Khaleesi took it a step further and applied this to climate change scenarios to look at how breadfruit habitat will persist over time. And bottom line is that virtually all, I think it's something like 85% of breadfruit habitat stays high quality in projected climate change scenarios. So if you're in a good habitat now, at least with current climate change projections, you're going to be in a good breadfruit habitat in the future. In general, breadfruit habitat in Hawaii and globally is going to expand as temperatures rise. Some places decline because of declining rainfall, but overall, we expect to see breadfruit becoming more and more suitable as our global climate changes. So in addition to these kind of tree surveys, we also have a range of variety trial sites across the state. So we have 10 sites. They're 30 tree plots with 6 different varieties of breadfruit in them, half-acre plots. And they're kind of spread out across ecological sites in the state. So we have places in old soils, in young soils, places in colder temperatures and warmer temperatures. And here we're able to standardize the management. So we treat them all exactly the same and are able to see how they produce in these different environments. These plots are still a little young. Here's a picture of our daughter when she was 3 and a 2-year-old ma'afala. This was our first fruit in our variety trials. The trees are now about 3.5 years old, and we're already getting substantial harvest off a number of the trees and able to start to connect yields to specific environments again. And other work we've done, this was about 10 years ago as part of my PhD, looked very intensely at the Kona region and how production in the trees changed with rainfall, soil age, and tree age as well. Uh, so again, we've done quite a bit of work in here, and just kind of want to leave you with a few key. So some key observations. One is that hot and low elevations generally do better. This makes a lot of sense. You know, Hawaii is actually a subtropical environment, and breadfruit is a truly tropical crop. So as we move into the northern and southern latitudes from the tropics, breadfruit habitat drops off. So here in Hawaii, we're actually kind of starting to push, the northern limits of breadfruit habitat. And so, yeah, in Hawaii anyway, the hotter you can be, the lower elevation you can be, generally the better. This also pertains to extremely low elevations, meaning salt spray. So we've found actually that small amounts of salt and our sites within kind of the salt spray zone actually perform better. I think this is because breadfruit has a really, really high cation demand, things like potassium, calcium, and so on, all of which are found in seawater. Um, but regardless, breadfruit can handle that salt spray really well and does seem to enjoy it. Another interesting thing I think we've noticed is that places with moderate cloud cover generally perform better than places that get full unclouded days, full sun all day long. And we've done some plant physiology work looking at photosynthesis and leaf yields and things like that. And essentially, breadfruit has a really strong ability to close itself up and shut itself down. All plants can do this to some degree. All plants have stoma in their leaves, and that's where they do their gas exchange. That's how they bring CO2 into the leaf to conduct photosynthesis. But a side effect of that is that plants evaporate water out of their stoma. And so most plants have what they call a late afternoon slump. So as the day gets really hot, a lot of plants will start to close up their stoma to reduce their water loss, and this also slows their ability to photosynthesize. We've seen breadfruit just completely shut itself down. Really, really strong ability to close itself up again. And so areas that have, partial cloud cover, on and off cloud cover through the day, they actually grow faster. They perform better than places that just get blazing hot, full sun all day long. You can moderate this a little bit with better irrigation, but it doesn't completely stop the process. So again, our areas that have intermittent cloud cover throughout the day tend to do better. Breadfruit also performs really well in a broad range of soils. Again, we've had sites and farms from extremely young rocky lavas on Hawaii Island all the way up to oxisol soils on Kauai. And breadfruit performs really well across the board. And this is kind of interesting. Most plants prefer a pH. Tomatoes like things slightly acidic. Other plants like things slightly alkalic. Most crops like to be right in the neutral zone. But breadfruit really does perform well in a really broad range of soils. The only exception we would add to this is compact soils. So kind of recently abandoned industrial agricultural lands where you've had a lot of heavy machinery and you've really compacted those soils down, breadfruit really does not do well in those settings. And what I think is happening is, again, breadfruit's a very shallow rooted crop, has very sprawling lateral roots. And I think in these compact systems, the roots can't get even a little bit under the soil. You know, usually they like to be just an inch or two below the surface. But in those compact soils, they're really pushed right up to the surface. They can dry out, can't access nutrients and water as well. So far, we've noticed very minor varietal differences in respect to the environment. And this essentially means that if your farm is a good habitat for breadfruit, it's a good habitat for all varieties of breadfruit. It's not like one variety does really well in the cold, or one variety handles a lot more moisture or sunlight than the other. They really all do seem to perform more or less equally well across environmental parameters. I would caveat this in that we are looking at a fairly narrow range of varieties, and we are only focused on Artocarpus altilis. So there are breadfruit that are hybrid varieties, hybrid species between Artocarpus altilis and Artocarpus marianensis, or Dug. And these hybrids perform really quite differently. And we are not actively monitoring those because they're really not widespread in Hawaii, and not really accessible in Hawaii at this time. So they may have some differences. Those hybrids are the varieties that perform really well on the low-lying atolls, with really high salinity, crushed coral soils, and there may be some differences there, but as far as the varieties we see in Hawaii and the ones that we're evaluating, again, not much difference in respect to environment. And this isn't really an environmental thing, but I did want to throw this in there because we see it a lot, is that the large grass competition has a huge impact on breadfruit tree growth and health. So, you know, California grass, Guinea grass, elephant grass, cane grass, whatever you call them, these really large invasive grasses. If you have them, you really need to keep them mowed down, and better to eliminate them. But again, I think because breadfruit is a shallow-rooted plant, and these big invasive grasses have really dense, really aggressive root systems, they greatly outcompete the breadfruit and retard its growth significantly. So with that, we'll move into varieties. Breadfruit is really quite diverse. So in this picture, the two central left fruit, the small green spiky one, is a bread nut, and that's the wild ancestor of breadfruit. And the one above that, the kind of other pin-cushiony one, is a meringue. But the other 6 fruit in this picture are all breadfruit varieties harvested here in Hawaii, just to show you some of the diversity in size and texture and appearance. A brief overview of kind of the mo'okuauhau of breadfruit. So again, you have Artocarpus camansi, or bread nut, is the wild ancestor of breadfruit, and it is believed that bread nut kind of evolved into 2 different species as well. So the Artocarpus altilis, or breadfruit, and Artocarpus marianensis, or Dug, which is commonly found up in Micronesia and the Philippines. Um, and then on the breadfruit line, you kind of have a further division of that true Artocarpus altilis is a fertile seeded fruit, and that still exists broadly. A lot of varieties are fertile and have seeds. But as people brought breadfruit across the Pacific and they started cloning their favorite varieties, through cloning after generations and generations and generations, they created genetic deficiencies in breadfruit. And at some point, you ended up with these sterile triploid varieties of breadfruit. And so, for instance, the Hawaiian breadfruit variety is one of these sterile triploids. So these are infertile, they cannot produce seed, they're always seedless. So I think that's a worthwhile distinction to make. And then you also have these interspecific hybrids where the breadfruit and the dug were crossed, and you have these Artocarpus altilis crossed with marianensis. And this produces another type of sterile breadfruit. And this is just kind of a visual representation of that. So starting in the upper left, you got your bread nut, and you can really see how seeded that is. Bread nut, people don't even really eat the flesh of the fruit, but you tend to let the flesh rot away and you collect all the seeds, and then you can actually boil and eat the seeds. They're kind of a lot like a chestnut. And again, that developed into the fertile breadfruit in panel B here. And then that fertile breadfruit, through human intervention over time, kind of ended up with these sterile, seedless breadfruit. And simultaneously, on the bottom, you had that dug, the Artocarpus marianensis. And then you have these hybrids between the dug and the breadfruit. And that produces, again, both seeded, fertile varieties as well as seedless, infertile hybrids. So there's a huge variety of breadfruit. I think if you take all the ethnography and all the documentation of breadfruit variety, there's something like 850 names of breadfruit that have been recorded. And the general rule of thumb in ethnobotany is it's about a 2-to-1 ratio of names to varieties, because a lot of times one variety will be given multiple names. But that still puts us at over 400 varieties of breadfruit in the Pacific, which is just amazing diversity and totally untapped diversity. Here in Hawaii, the work of the Breadfruit Institute, Dr. Diane Ragone, she has assembled the world's largest germplasm of breadfruit varieties. So they have almost 200 accessions representing over 150 varieties of breadfruit over on Maui at the Kahanu Gardens, part of the National Tropical Botanical Gardens. And so we have quite a substantial resource in terms of breadfruit varieties here in Hawaii. When you look at a variety and try to identify it, there's a number of things you might want to look at. So there's the overall tree form, how compact or sparse it is, how erect it is or how much it likes to spread. But basically just kind of the overall form of the tree. You have the leaf shape. So is it lobed? Is it unlobed? Is it deeply lobed? How many lobes does it have on the leaves? The leaf texture. So in particular, kind of how glossy is it? When you look at it from a distance, is it kind of shiny, or is it more of a matte type of coloration? How hairy it is it pubescent, or is it smoother? The fruit shape is a big one. Is it round, oblong, irregular shape? And also the texture of the fruit, how smooth or bumpy the skin is. And then, of course, is it seeded, and how many seeds does it have? So all of these can be hints as to the variety that you do have. So just to look at some of the diversity, so here's kind of the fruit shape. Here in Hawaii, vast majority of what you get is either round or oval. We do have some heart-shaped and irregular type breadfruit in the state as well that are common. Skin texture, again, the first 6 here are all breadfruit varieties, and then number 7 is the bread nut. But again, they go from almost perfectly smooth to extremely bumpy, sometimes even little spikes on the top of the bumps. So this can be a really telling characteristic. And again, the leaf shape, and how lobed it is. And here you have a virtually unlobed leaf, a normally lobed leaf, and then what we would call a very deeply lobed leaf, where the indentations of the leaf come in almost all the way to the midrib. So Hawaii has quite a lot of varieties. There's only a handful of really common varieties, but there are a lot of varieties out there. Wilder, back I believe in the 1930s, he brought like 32 varieties of breadfruit in from Tahiti and the South Pacific. There's been a lot of varieties introduced by other Pacific Islanders who have immigrated to Hawaii. Some varieties have been distributed commercially. So we're not positive, but I think there's probably about 50 or so varieties floating out there in backyards and farms, and so we have a germplasm of about 30 varieties on the Big Island. And again, that said, probably 90 to 95% of the production in Hawaii is really only 2 varieties, the more common ones. So we'll kind of look at some of the most common varieties here and talk about them quickly. So of course we have to start with the Hawaiian variety. This is actually a common East Pacific variety. You can find it in Tahiti and elsewhere as well. In other places it's known as ulu maori. Here in Hawaii, it's believed that this was the only breadfruit variety introduced before European arrival, and so you don't really hear it called ulu maori because there was only one uru. So people just tended to call it ulu. A lot of people today just call it the Hawaiian variety, but uru maori would be a more accurate name. Another common variety, pretty well distributed in the state, is maopo, also called ulu hamoa elsewhere in the Pacific. And this is one of those varieties that has an almost unlobed leaf. It's the only common variety in Hawaii that is virtually unlobed. So that's a pretty easy one to identify here. And then ma'afala has become kind of the global standard for commercial production. It's the variety that's been distributed the most through propagation. And so this is a really, really common variety. It was given away a lot in tree giveaways. A lot of farms bought them from commercial nurseries when it was available. And people tend to like it because it is a little bit more of a compact tree. It can still get really, really big, but in general, its growth is just more compact. When you look at an average breadfruit tree, you can look right through the tree. There's lots of light gaps. Ma'afala, it tends to be when you look at the tree, you can't see through it. The branches are close together, the leaves are close together, and yeah, just a very dense tree. Um, Pu'o is probably the next most common variety in Hawaii. Um, the leaves of this tree can kind of look a lot like the Hawaiian variety, but it does tend to be a smaller statured tree. It has a really long peduncle. The stem of the fruit is really long, and where the stem attaches to the fruit, there's a very distinct ring, kind of a nipple that goes around the fruit right where the stem attaches, is kind of the real telling characteristic of Pu'o. Um, the rest of the trees are kind of less common, but they are out there. They're not that rare. So we'll cover some of those as well. So Afara is a really cool variety in that, as you can see, the skin of the fruit turns red. Um, and that's a very telling characteristic, pretty easy to recognize if you see it. Um, but fairly common on the Big Island, and a number of nurseries do sell that tree on occasion. Um, Pua'a and Otea, these two varieties were both distributed by Global Breadfruit, which was a big commercial production of breadfruit through tissue culture. And so a number of farms and other locations acquired these varieties when they were available. And so you'll find them fairly commonly across the state. Um, Lipit, I'm still not sure where this name ever came from, but at least on the Big Island, there's quite a bit of Lipit out there. As you can see, it's an irregular shaped fruit. It has a really, really bumpy skin, and it's much, much lighter than any of the other varieties that are common in the state. Really light and flaky texture to the fruit. If you held a Lipit in one hand and a Hawaiian variety in the other hand, if the fruits were the same size, Lipit would weigh like half as much. Very, very light fruit. Um, and last couple common varieties, Fiti, really, really beautiful fruit. They just make these perfectly round yellow cannonballs of a fruit. Again, has a really long peduncle, a really long fruit stem that attaches to the tree. Um, a lot of people really like this one for taste and texture. It's a really good producer, pretty popular on a number of farms. It is a seeded variety. It tends to have, 2 or 3 seeds per fruit, which the processors don't like as much, but it is a really good high quality fruit. And one last one, the Mine Paddock, seems like it was one of the early introductions, and fairly widespread across the state. Pretty decent producer as well. Um, so again, we haven't noticed a lot of differences in the varieties as far as how they perform in different environments, but there is a huge difference in the fruit itself. So texture, they're wildly different. Again, their density, their flakiness, their moisture is all quite different. And this is especially important if you're going to do any sort of processing or, yeah, what you want to do with the fruit after you harvest it. When you take a lighter variety of breadfruit and you steam it up and you blend it, um, you'll get something like a hummus. If you take a really dense variety like a Farah and you steam it up and you blend it, you're going to get something like a poi, really thick and sticky. And yeah, so to me, this is kind of the biggest difference and consideration in terms of your varieties. Um, and as you'll see in our next section here, they do also differ in their seasonality a bit. And so if you're looking to spread out your harvest throughout the year, having diverse varieties can be really useful. um, so yeah, kind of a final section here on phenology. Um, we just wrapped up a really big statewide project looking at seasonality of breadfruit across the state. And I'll apologize because we haven't fully had time to delve into this data set yet. So we kind of really briefly pulled out some of the key things that we'll share with you here. Um, but first, the overview. So breadfruit, from the time it emerges, will take about 18 to 20 weeks to fully ripen on the tree. Um, for the first approximately 14, 15, 16 weeks, it's kind of considered immature. And then you have about a maybe 2 week window of a good high mature fruit. And this is really where it has laid down its starch reserves, and it performs more like a staple carbohydrate. And then as you pass that stage and the fruit fully ripens, the fruit softens, um, and it changes dramatically in terms of nutrition. So the fruit changes. For instance, some of the latex gets converted into fatty acids. Some of the starches start getting converted into sugars. So the fruit gets softer, it gets sweeter, it starts to taste and perform more like a plantain. Um, in the immature stage, to me, there's not a lot you can do with it. But at the baby stage, the first 2 to 3 weeks of its emergence, when it's golf ball sized or maybe a little bigger egg sized, um, it performs much more like a vegetable. It's crunchier, it doesn't have any starches yet, it's higher in vitamins and minerals, and you can pickle it, you can use it in salads. So as the fruit ripens, it goes through a number of these stages. Um, so here's a couple ugly graphs we pulled out from some of our recent work. And this is just looking at diameter in the blue line and weight in the red line. Um, and so you can kind of see, you get pretty steady increase in size and weight for the first, um, you know, uh, 12 to 15 weeks. Um, well, size, you get increase for the first 12 weeks or so, and then it really levels off. The fruit doesn't get any bigger, but you can see that the weight is still increasing, even though the fruit isn't getting any bigger. And that's really the fruit laying down its starch reserves, becoming more carbohydrate rich, becoming denser, and increasing in weight. And then you can actually see that big downtick in the last section of weight. And that is, again, those starches getting converted over to sugars, the fruit burning up a little bit of its energy and actually getting lighter as it ripens. Um, and here is those starch reserves. And again, you can see that until about week 12, you kind of have really no starch development. In fact, you actually just have declining starch for the first 10 or 11 weeks. And again, that's that whole immature stage where to me, man, there's just really nothing you can do with that immature stage. The fruit is big, but it's got no starches, no carbohydrates, and it's just kind of a weird texture and rubbery and then yeah, right at week 12, your starches just start getting laid down and they really skyrocket up until you hit that kind of peak maturity around weeks 18 or 19. And then just looking some other characteristics. So this is protein in the blue, fiber in the green, and fat in the red. And just kind of showing that they all follow kind of a similar pattern. Where in that baby vegetable stage, they have reasonable levels. Again, for the first 2 or 3 weeks, you see that those levels are kind of stable or increasing. And then about week 5, they all decline precipitously. So that week 5 to 15, again, that's that immature stage that the fruit suck. And then you kind of turn the corner at week 15 and you start developing more fats, more protein, more fiber really rapidly in those last few weeks. And in particular, when you look at things like fiber and protein, I mean, you see how they really jump up in the last couple weeks. And so harvesting at that proper maturity stage is really important. It makes a big difference in the fruit quality and how you can use it. And then here's some of your minerals: nitrogen, potassium, calcium. Um, and I think the point I wanted to drive home with this is that the baby fruits, weeks 1, 2, 3, have a really, really high mineral content. They have a higher vitamin content. They really are more like a vegetable in that really, really baby stage. And so you can use them for entirely different things at that very, very young stage. And then, yeah, we'll kind of end here talking about seasonality. This is obviously really important for producers. Um, like I said, we just had a statewide citizen science project wrap up. So for about 2 years, a little over 2 years, we had 250 participants across the state, and they monitored about 450 trees. And every 2 weeks for the 2 years, observers would go out, look at their tree, and fill out the data sheet around how many flowers and immature fruit and mature fruit their tree had. And so we were able to generate some really good data from that, which again, we haven't fully had a chance to delve into and digest yet. But just pulling out a couple things. So here is looking at just the Hawaiian variety in across the whole state, and you can really see the seasonality peak. And this is pretty typical of what we've seen, where your season will start turning on about July. You'll start to see the first fruits of the season maturing. And then you get a pretty steady increase through the fall, and then this huge peak, usually around October, November. Varies from year to year a little bit, but really substantial peak. And then just the other thing I want to point out is that it doesn't go down to zero ever. Even the deviation, the range of fruit. So we have the blue line, and then you have that shaded blue area. Even the shaded blue area doesn't go down to zero. And what that means is that for the most part, you can always find a fruit throughout the year on a tree or a set of trees. So while there's clearly seasonality, there is also annual production, and you can also see a little bit of a second season here around March time. And this data is paralleled by what we see with the industry. So in working with the Hawaii Ulu Cooperative, this is just some of their farmers' production data. And pretty similar patterns. Again, you see starting in July at month 6, a pretty steady increase. You see a big peak around October, November, declining, and then probably because they're more vigilant about harvesting, you really see that second season again, kind of March, April time of the year. And again, the seasonality of production is governed a bit by variety. So there are some differences in seasonal production of variety, but it's not huge. You know, it shifts the season a month or two in one direction or the other. So here's kind of looking at 3 common varieties in Hawaii. This is work by the Breadfruit Institute. And so showing Ma'afala, Ulu Fiti in the brown, and then Ulu Hawaii in the dark green. And again, you can see that Ma'afala is a little bit earlier. Ulu Hawaii is a little bit later, you know, but in general, you still are hitting that peak around October time, and your season's kind of turning on, you know, around June, July. So here's more work by the Breadfruit Institute. Again, just looking at a broader range of species, of varieties of breadfruit and their seasonality. And again, just kind of want to highlight that, you know, there are some differences. You can shift the seasonality a few months earlier or later by the use of different varieties. But there are limitations to this. Even across a larger section of varieties, you know, you still have a lot of yellow, light green, and kind of that April, May, June area. You still have a lot of dark green in that September, October, November area. And so your peak season of most varieties is still going to come out in that late fall, early winter, and you still are going to have a lean season in kind of the late spring, early summer. So yeah, so I mean, you can use varieties to help spread out your seasonality, but there are again just limitations to how variable the varieties are. So just something to keep in mind. So with that, we'll leave you with a picture of our son, Io, on a 1,000-pound ulu harvest right here. Just want to say thank you, especially give a shout out to Saleh and Kahumana Farms for providing a platform to help us share. And yeah, please do feel free to reach out. My email is nlincoln@hawaii.edu. We're always happy to try to help farmers or other producers out there. You know, we certainly don't have all the answers, but you know, we have been working with a lot of farmers, a lot of producers, and coupling that with research to try to understand this crop better. So yeah, anyone ever wants to talk ulu, feel free to reach out. With that, I'll say aloha, and thank you all for listening, and hopefully we'll see you guys in person for workshops 3 and 4. All right, take care.